Orbital and escape velocity. Later in the semester, you'll be able to derive these if you want, but for right now, I'm just going to give them to you. There are a couple of things you need to know here. So the orbital velocity is the square root of g m over r. This g is the universal gravitational constant, and it's not something you're going to memorize. It's not all that large. It's 10 to the minus 11th or so, and but it's a constant, in quasi-constant over the scale of the universe. M is the mass of whatever you're orbiting. So in our case, it's usually the Earth or the Moon or the Sun or something like that. It's the mass of the object you're orbiting. Now here's the thing. The mass of the satellite, the mass of whatever's doing the orbiting, is not in this. And that's an important point when you start talking about what we do with satellites. If the mass of the satellite determined the orbital velocity, then satellites at the same distance from the center of the Earth would have different velocities depending on their mass, and they'd run into each other. Well, it turns out it doesn't depend on the mass of the satellite. It only depends on the mass of the Earth. And this r in here is the distance you are, not from the surface of the Earth, the distance you are from the center of the Earth. And so you've got to take whatever elevation you are above the surface and add the radius of the Earth to it to get the right distance in some of the problems. Now, escape velocity is greater than the orbital velocity by a factor of square root of 2. And you can see it right here. You've got square root of 2 gm over r, or 2 gm over r, and you take the square root of that. G, again, is the universal gravitational constant. M is the mass of the Earth. R is the radius. If you want the gravitational force, and here it says between two planets, but reality, between any two objects, if you want their gravitational force between them, it's G times the mass of the two objects multiplied together, divided by the distance between them squared. All right, so G m1, m2 over r squared gives you the gravitational force between any two objects.